So hello everyone, I am back with another new video based on gravitation. Today's lecture is based on the topic called Newton's cell theorem. So basically Newton has given two cell theorems. This is very much versatile for calculating the force, gravitational force experienced by any point mass. So basically there are two theorems. These two theorems are used in two different cases. One, when any point mass is outside or inside of any spherical cell. Or solid sphere as well. So now let's discuss this first case where any point mass is exactly outside the spherical cell. Let's say there is one spherical cell of radius capital R, and this spherical cell has a center at O, and this spherical cell can be actually hollow from inside and as well as it can be solid also. So in both the cases we have the same formula and same concept. Let's say mass of this bigger spherical cell is capital M, and there is another mass which is exactly point mass and whose name is point P mass, and its mass is M dash. Distance from the center of the bigger spherical cell to the point mass is, let's say, small r. As you can see clearly from this figure that small r is greater than capital R. So the force experienced by this small point P mass will be equal to g times of mm dash divided by r square. This is very simple, which we have already studied in Newton's law of gravitation. So the second and most crucial thing is that when the point mass is exactly inside the spherical cell, then how do we calculate the total experience force, gravitational force by the particle mass or point mass? So how we will demonstrate this? Let's say there is a really big sphere of radius capital R and center O, and inside this spherical cell there is another point mass whose mass is exactly m dash, and its name is, let's say, P. So the question is, what will be the gravitational force experienced by this point mass whose mass is m dash, which is inside the spherical cell? Let's say mass of this bigger spherical cell is m capital M. So for calculating the gravitational force experienced by this point mass whose mass is m dash, which is inside the spherical cell, we have to first draw an imaginary cell inside the bigger cell. As you can see, small r is lesser than the capital R. So the question is, what will the force experienced by this m dash mass due to the presence of this bigger cell? Actually, this outer mass, which is outside the imaginary dotted cell, will be neglected. We have to neglect this mass. This mass has to be neglected in order to calculate the total gravitational force experienced by this point mass m dash due to the presence of this bigger cell. Mass of this shaded portion has to be neglected. Mass of this shaded portion has to be neglected in order to have the exact answer, which is gravitational force experienced by m dash mass. Let's say the remaining portion that is inside the dotted sphere has a mass of mr. mr. What is mr? mr is mass of dotted sphere. डॉटेड स्फीयर का मतलब ये जो अंदर स्फीयर है इसका मास, ये जो कलर्ड स्फीयर है इसका मास नेग्लेक्ट करना पड़ेगा. सो दैट विल बी F equals कैपिटल G टाइम्स कैपिटल M. कैपिटल M मतलब बड़े स्फीयर का मास इनटू में m डैश नहीं लेना है, हमको क्या लेना है mr, मास ऑफ दिस स्फीयर व्हिच इज डॉटेड. एक्चुअली डॉटेड स्फीयर का मास, तो डॉटेड स्फीयर का मास है mr डिवाइडेड बाय रेडियस स्मॉल r स्क्वायर. So this is how we study Newton's cell theorem. Sorry, please pardon me. Actually, there is no one to assist me, so I have to watch again and again whether the video is exactly being recorded in the camera or not. You can see it from here. Now it is very clear. So this is how we study the Newton's cell theorem. Okay, let's proceed to the further concept. So before that, let me explain this whole cell theorem again. There are two cell theorems given by Newton. One is valid for both are valid for point masses only, when point mass is outside the spherical cell, and another cell theorem is when point mass is inside the spherical cell or solid sphere. Basically, the question is, what will be the force experienced by this point mass whose mass is m dash, which is outside the spherical cell? How we will calculate that? Because Newton has given gravitational law of gravitation, which is only valid for point masses. There is one point mass. Yes, we have one point mass, but another mass which is in the form of a sphere is not a point mass. So we have to imagine that the entire mass is exactly situated on the center of mass, that is O. Now, from center of mass to the m dash mass, the distance is, let's say, small r. So we can apply Newton's law of gravitation for gravitational force, that is G times m dash divided by r square. Second thing is, when point mass, that is m dash, whose name is P, is exactly inside the spherical cell. Let's say the radius of the bigger cell is capital R, as we have already taken in the previous diagram, and the point mass, whose name is P and mass is m dash, is inside the spherical cell. Now we have, the question is, what will the mass, what will the gravitational force experienced by this m dash mass which is inside the spherical cell? How will we calculate that? See, we have to neglect the outer mass. What is the outer mass? Listen, let's say m dash mass is inside the spherical cell. We have to draw a dotted sphere. What is dotted sphere? This is nothing but, as it's a kind of tool which we use to neglect the outer mass, which is already shaded. So F equals to G times mass of bigger cell, that is capital M, times mr. What is mr? Mr is mass. I'm writing it here. Mr equals okay, sorry, I have already written it. Mr is mass of dotted sphere. So Mr is mass of dotted sphere. Dotted sphere मतलब inside का mass. So F equals to gm times of Mr divided by r square. As you can see, the difference is here small r is greater than the capital R. As you can see it from the diagram also. But in the second case, small r is lesser than the capital R. हमेशा इस वाले केस में क्या करना है, सिर्फ और सिर्फ अंदर का मास लेना है और जो बाहर का मास है, ये जो पेरिफेरी का मास है, इसको नेग्लेक्ट कर देना है, इसको डिड्यूस कर देना है, माइनस कर देना है. Okay everyone, so we have a question that a mass m dash capital M is broken into two parts of masses m1 and m2. How are m1 and m2 related so that the force of gravitational acceleration between the two parts is maximum? What is the question? Let me make you understand. Let's say there is a bigger mass, that is capital M. This bigger mass is broken into two parts, two small parts. Let's say mass of this first part is m1 as per the question. M mass is broken into masses m1 and m2, and the second part's mass is m2. Now the question is how we have what should be the relation between m1 and m2 so that the gravitational force between the two parts is maximum. Let's say the distance between the two masses is r. The question is what is the relation in m1 and m2 so that gravitational force between the two becomes maximum. In order to have maximum gravitational force between the two masses, how we have to break this bigger mass into m1 and m2. Basically we have to establish relation in m1 and m2. So let's say mass of this m1 part is m. So obviously mass of m2 will be mass of bigger sphere minus m dash. क्या क्वेश्चन है, फिर से बता देता हूं. एक कोई बड़ा सा स्फीयर है जिसका मास है कैपिटल एम, उसको दो पार्ट्स में तोड़ा गया है m1 और m2 मास में. बोलता है m1 और m2 किस तरीके से ब्रेक किया जाए, मतलब क्या मासेस रखे जाए ताकि उनके बीच का जो ग्रेविटेशनल फोर्स हो मैक्सिमम हो जाए. तो मान लीजिए जो m1 मास है एग्जैक्टली इसका मास आता है m डैश, तो जाहिर सी बात है जो m2 मास है उसका मास क्या हो जाएगा, इस छोटे वाले मास को इस बड़े वाले मास से निकाल दें, मतलब m माइनस m डैश. ओके, एज फॉर दिस क्वेश्चन जहां तक हमने अभी सॉल्व किया इसके हिसाब से ग्रेविटेशनल फोर्स कितना होना चाहिए, F इक्वल्स टू कैपिटल G टाइम्स m डैश एंड मल्टीप्लाइड बाय m minus m dash divided by distance between two masses, that is r, small r. m dash को अंदर भेज देते हैं तो यहाँ पे आ जाएगा कैपिटल m डैश माइनस में m डैश स्क्वायर डिवाइडेड बाय r स्क्वायर. अब इसको डिफरेंशिएट कर देते हैं. On differentiating this equation with respect to dm, ये हो जाएगा बेटा d dm ऑफ f बराबर g डिवाइडेड बाई r, दोनों ही कॉन्स्टेंट्स हैं, g डिवाइडेड बाई r स्क्वायर, इसको बाहर कर लेते हैं, अंदर बचता है d dm m डैश, एक्चुअली यहाँ पे हम m डैश ने लेट किया तो m डैश से डिफरेंशिएट करते हैं एंड m डैश के रिस्पेक्ट में, तो देगा d dm डैश mm dash minus m dash square. Let me see whether everything is clear in the video. Yes. Okay. यहां पे कर देते हैं, तो यहां से अगर देखें तो आ जाएगा d dm dash of f बराबर g डिवाइडेड बाई r स्क्वायर। अब डिफरेंशिएट करेंगे तो यहां बचेगा सिर्फ और सिर्फ m माइनस साइन के साथ d dm डैश ऑफ m डैश स्क्वायर, इसका हो जाएगा डिफरेंशिएशन m डैश स्क्वायर का 2m डैश। In order to have the maximum gravitational force, मतलब फॉर f max क्या करना पड़ता है हमको, d dm ऑफ f को जीरो करना पड़ता है, d dm डैश ऑफ f मस्ट बी इक्वल टू जीरो। इसका मतलब ये पूरा टर्म जीरो हो गया, तो कह सकते हैं कि g डिवाइडेड बाई r स्क्वायर मल्टीप्लाइड बाई कैपिटल M टाइम्स माइनस 2m डैश इक्वल्स जीरो। तो यहाँ पे आएगा कैपिटल M माइनस 2m डैश इक्वल जीरो एंड ये हो जाएगा m इक्वल्स 2m डैश। ये रिलेशन है दोनों में, और m क्या था, यहां से हम देख सकते हैं m डैश बराबर आता है कैपिटल M टाइम्स कैपिटल M डिवाइडेड बाई 2। तो कहने का मतलब दोनों में रिलेशन क्या है, तो यहां से हम निकाल सकते हैं कि ये जो m डैश आता है यानी m1 जो है m1 इस बड़े वाले मास का आधा होता है, और ये वाला भी आधा हो जाए। मतलब अगर हम बराबर मासेस में दोनों को ब्रेक कर दें, आधा आधा, m है कैपिटल M, उसको आधा आधा तोड़ दें, तो दोनों के बीच ग्रेविटेशनल फोर्स जो होगा वो मैक्सिमम होगा। इस तरीके से हम सॉल्व कर सकते हैं इसको। So this is how we can solve this question, as you can see it in the solution. Okay, I hope everything is clear till now. So first thing we have discussed is Newton's cell theorem. There are two Newton's cell theorem. One is for when point mass is outside the spherical cell or any solid sphere, and when second is when point mass is inside the spherical cell. For first case, that is when point mass is outside the spherical cell, there is a simple concept, that is the concept of center of mass. Means mass of the entire spherical cell or solid sphere has to be assumed that the center of mass is the position where the entire mass exactly lies of the bigger sphere. So from there we have to consider a small distance, that is small r, to the point mass, that is m dash, जिसको हमने पीसीएम में किया था। तो वहां से सिंपल हम लिख सकते हैं कि f इक्वल्स टू कैपिटल G टाइम्स ऑफ mm dash divided by small r square. Second case में when the point mass is outside of the when point mass is inside the spherical cell, इसका मतलब क्या है कि second case में small r, that is that you can see from the diagram also. You can reverse the video. So there you will find that the small r is exactly lesser than the capital R. So for that, the entire mass which is exactly outside the threaded sphere has to be neglected, means you have to subtract the mass which is studded mass of the sphere, and only mass that can be taken in the formula is which is inside the dotted sphere. तो उस तरीके से हो जाएगा मास. लेट से डॉटेड स्फीयर का जो मास है वो mr है, तो उस हिसाब से फॉर्मूला बनेगा F इक्वल्स टू कैपिटल G टाइम्स ऑफ कैपिटल M टाइम्स mr डिवाइडेड बाई स्मॉल r स्क्वायर. उसके बाद हमने एक क्वेश्चन किया कि एक कोई बड़ा सा स्फीयर है जिसका मास है कैपिटल M, कैसे इसको ब्रेक किया जाए दो पार्ट्स में, यानी m1 और m2 में कैसे तोड़ा जाए कि gravitational force between the two masses, that is m1 and m2, becomes maximum. So for that we have to bracket in m1 and m2. For that we have to consider that the mass of m1 is let's say m dash. So उस हिसाब से m2 का मास हो जाएगा बड़े वाले स्फीयर का मास माइनस m dash, यहाँ पे हमने लिख दिया. उसके बाद हमको पता है कि what is the formula for gravitational force between the two masses, that is capital G times of m dash multiplied by m minus m dash divided by r square. Sorry, pardon me please, यहाँ पे r square होना चाहिए था. उसके बाद फिर इसको हमने m dash को अंदर भेजा, इसको सॉल्व किया इस तरीके से पूरा करके. उसके बाद हमने dm dash के रिस्पेक्ट में इसको डिफरेंशिएट कर दिया वो दोनों तरफ. तो आपको पता है कि यहाँ पे हो जाएगा ये g और r स्क्वायर क्या है, कांस्टेंट, इसको बाहर कर लेंगे. अंदर जब डिफरेंशिएशन करेंगे तो ये m बाहर आ जाएगा, m डैश d m डैश ऑफ m डैश हो जाएगा 1. तो मतलब यहाँ पे क्या बचेगा, यहाँ से देख सकते हैं, यहाँ से m बचेगा और आगे m डैश स्क्वायर का डिफरेंशिएशन हो जाएगा 2m. इस तरीके से पूरा सॉल्व करने के बाद हमको पता चलेगा अगर मैक्सिमम फोर्स हमको चाहिए तो ये d m डैश ऑफ f 0 होना चाहिए. तो इसको पूरा हमने 0 कर दिया, 0 के बराबर, ये पूरा 0. यहाँ से इसको दूसरी तरफ लेंगे तो 0 हो गया, सिर्फ यहाँ पे बचा m माइनस 2m डैश इक्वल्स 0. यहाँ पे सॉल्व करने पता चलता है कि m डैश मस्ट बी इक्वल टू m डिवाइडेड बाय 2, मींस दिस बिगर स्फीयर हैज टू बी ब्रोकन इनटू टू इक्वल पार्ट्स. मतलब m by 2 आधा आधा ब्रेक करना पड़ेगा in order to have the maximum gravitational force between the two masses. Thank you so much. That's it for today. Let's see